Everybody, welcome to our inaugural lecture of the TDAI Speaker Series. And today's lecture is by Dr. Karen Bakker. This speaker series, I would like to introduce take this opportunity also to introduce our speaker series, and looking ahead, we will have talks, so please do hold time on your calendars. You can get all the information from the TDI website with the upcoming talks on November 12th by internal TDI faculty, and then November 19th, the Bruce Acree Memorial Lecture by David Laser, and the whole schedule is posted. We are delighted today to start our series with Dr. Karen Bakker from the University of British Columbia. Dr. Bakker is Canada Research Chair and Professor at the University of British Columbia with expertise in environmental governance, innovation, and digital technologies. She is also the director of the program on water governance and leads international comparative study of water energy at the Water Energy Nexus. Dr. Bakker is also a Pierre Elliott Trudeau Foundation Fellow and member of the Royal Society of Canada's College of New Scholars, Artists, and Scientists. She's a member of the board of International Institute for Sustainable Development, the Scientific Advisory Council of the Council of Canadian Academies, the Research Council of the New Digital Research Infrastructure Organization, and the Governing Council of the Federal National Research Council. She regularly acts as an advisor to national and international organizations, including currently UNEP. Dr. Bakker has been the recipient of Canada's Top 40 Under 40 Award, the Annenberg Fellowship in Communication from Stanford University Center for Advanced Studies in the Behavioral Sciences, and a Cox Visiting Professorship. Her work is recognized by SSHRC Impact Award in 2017. And today's talk is at the intersection of environment, policy, and digital technology. And with that, I introduce Dr. Karen Bakker and the talk, Digital Earth, the Future of Environment Governance in a Wired World.
Thank you so much for the warm welcome, Tanya. I should say that the bio forgot to mention just two things. One, that I have two daughters and I have a very rambunctious cat, which may appear at any time in these live proceedings. And so I apologize in advance if there are any disruptions. I'm also very grateful, Tanya, for you inviting me. I should say I really admire your work. I regret I am not there in person to meet all of you. I've heard about some of the fascinating work that you're doing at your institute. So I hope that in better times we'll be able to connect in person. So with that, I'll share my screen and I'll begin the presentation. I'll begin by noting that this is a work of synthesis that will provide an overview of innovations in technology and cutting-edge science across a broad range of disciplines, ranging from computational sustainability to ecological informatics and the digital humanities. But I should caution you from the outset, I am not an expert in any of these disciplines. So in putting together this synthesis, which constitutes the basis for part of the argument in a forthcoming book that I'm publishing with Princeton University Press, I'm definitely stepping out of my area of expertise. So I really welcome your feedback on the various ideas and themes that I arrange across in this presentation, and really do appreciate frank and robust criticism to look forward to your questions. With that, I'll begin by arguing that we are at a turning point in the environmental agenda. And I'm very excited about this turning point, although it poses many risks. What I'm going to outline for you today is an argument that, subject to certain caveats, makes claims that we are going to be able to radically enhance our ability to protect and conserve the environment and mitigate hazards in the 21st century because of our growing ability to apply a broad range of digital tools to environmental governance. So I'll make this argument in 4 parts. I'll begin by giving you some background on the meta-analysis that I've done over the past 5 years. I'll then briefly give you examples of 5 categories of applications that are rapidly proliferating. This is a very exciting field. I'll then briefly discuss digital Earth governance innovations that is distinct from the technologies, the different and new ways in which we are able to proceed with environmental regulation and protection. And finally, I'll talk about some of the very significant challenges we face if this ambitious agenda is to be realized. So I'll begin with the meta-analysis. So this is what I've spent the past 5 years of my life doing. As a little bit of background, I originally trained in physics, but I did a BA as well as a BSc. I then did a PhD at the Oxford School of Geography and Environmental Sciences, where I was co-supervised by a natural and social scientist. So I have long sustained an interest in digital innovation. This was the focus of my sabbatical fellowship at Stanford in 2015, which is where this project really began. And I've spent the past 5 years immersed in research, not publishing very much, to get a sense of this rapidly expanding landscape of technological innovation. To give a bit of a sense of context for those who are not familiar with this field, you can think about the ecosystem, to use the tech definition of that term, in 3 components. The first is instrumentation. And of course, you'll know that the rapidly decreasing cost of instrumentation combined with the rapid decrease in size means that we now have the ability to deploy fairly complex instrumentation at a fairly low cost across the Earth's surface. And this has led to an exciting range of applications, and I'll give you a brief highlight of those in the following section of the presentation. Instrumentation, though, is not sufficient. It's necessary, but not sufficient for the digital Earth revolution that I'm talking about. The second component is interconnectedness. So ICT technologies, Internet of Things, and of course, environmental sensing networks. Cloud-based computing, of course, enables the sharing of the tsunami of data that is generated through this combination of instrumentation and interconnectedness. And what this does is it actually reverses one of the most important constraints on effective 20th century environmental governance. That is, scarcity of data was the norm in the past, and in the future, an abundance or even a superabundance of data will be the key challenge we have to deal with. This is where intelligence comes in, and there are a huge range of topics I won't have a chance to address today. Machine learning is only a kind of crude label for the various ways in which these technologies combined enhance and transform our cognitive capacities. The other thing I'll say about this is that from a digital humanities perspective, what is fascinating about these technologies is that they distribute sensing capacity between humans, machines, computers, and organisms. The increasing use of non-human organisms as vectors for sensors, and the degree to which we now rely on, for example, digital bioacoustics and ecoacoustics for ecosystem sensing in a manner that extends our auditory hearing capabilities into the infrasonic and ultrasonic range is an example of what I mean when I say that digital Earth technologies enhance our sensory capacities as well as our cognitive capacities. And this is somewhat similar to, although very different in scale, of course, to the revolutions entailed by both the microscope and the telescope. An enormous number of organizations are jumping on the digital Earth bandwagon. Now, this actually has a long history stretching back to Al Gore and earlier thinkers like Teilhard de Chardin. So I don't have time in today's presentation to give you the full sense of that very complex and interesting history. Instead, I've just put up a logo salad here to indicate that you have government actors, you have big tech, you actually have a lot of interesting research initiatives, Data One, for example, And so this is a very complex landscape of actors that are in a race at the moment to harvest and then sequester and control the world's environmental data. And the relative lack of oversight of this is actually one of the key focal points for my collaboration with UNEP, the United Nations Environmental Program, because clearly this sector is innovating around environmental data monitoring and the monetization of the data in a way that the global and national regulatory frameworks have simply not kept pace with. So this has raised a lot of criticism. For those of you who follow these debates, debates about platform capitalism or surveillance eco-capitalism have signaled concerns. So Shoshana Zuboff, for example, at Harvard, her seminal work on surveillance capitalism presents an argument that many, or if not most of these technologies, if adopted by big tech companies, are inherently problematic. I don't fully agree with that argument. I believe that these technologies can be mobilized for a variety of purposes. So although I understand the important caveats that one should apply at this current economic conjuncture of relatively light touch regulation, nonetheless, I think it's very important as scientists to think through the ways in which these technologies could be used for good. So with that, I began my research. One of the first things I did, and I continue to maintain, is a database of academic literature on these topics across the humanities, social sciences, and natural sciences. Max Ritz and I published an article on this in 2018. And the synthesis that we have conducted underlies some of the arguments I'm going to make later in the paper. The other thing I've been doing is just keeping track of the innovative tech applications that have been developed over the past 10 years. By 2017, I had gotten up to nearly 4,000 of them. They're spread across a wide variety of fields, including not only the ones you might expect, like AI or artificial life, but also distributed ledger technology and even some very interesting developments in the arts and leisure. And along with the book, I'm going to be publishing an interactive database where you can search these examples, much like the Biomimicry Institute does on its asknature.org website. Because I think one of the most amazing things about this field is the diversity of innovation, but also the relative lack of information sharing across the different disciplines in which innovation is occurring. And my hope is to stimulate cross-fertilization between fields by publishing that database. The database also drills down into some specific ecosystems of concern. So this is an example of a timeline we put together on smart oceans. That is the gradual proliferation of digital technologies to monitor various aspects of marine ecosystems. So this is like a teaser for the eventual database I'll publish. I won't be able to go into it in detail today, but this signals the level of detail at which my team has been looking at these issues over the past 5 years. One of the very interesting points about this is the extent to which these new technologies enhance our ability to study a much larger number of species. So one of the things we did is put together a list of all of the species to which digital bioacoustics technologies has been applied, and it's well over 1,000. This image uses, if you're familiar with it, the method developed by Hinchcliffe, the Open Tree of Life format. So one of the points I'd like to leave you with, as I've just demonstrated and given you a brief overview of the background research I've done for the book, is this sense that future historians of science will look back and say that this decade and subsequent decades were an era when we were gradually applying digital technologies to the tree of life. One can imagine that 10 or 15 years ago, this graphic would have been nearly empty. 10 or 15 years from now, it would be much denser. And one can imagine a future in which a large proportion, if not a majority, of species on the planet have had some sort of digital monitoring application applied to them. And what that opens up, of course, in a manner analogous to the microscope, is a whole set of worlds of fascinating discoveries, not only with respect to the behavior of organisms, but also perhaps with respect to the impacts of human actions in the environment. So I won't say more about that, although Tanya, I do want to talk to you about a potential collaboration around the bioacoustics research, so we should follow up on that. But I'll move into the next section of the presentation. And here I'm going to illustrate very briefly the power of some of the applications across a broad range of sectors, simply to give you a sense of the scope, scale, and diversity of the digital Earth ecosystem. So there are 5 categories, and the first is monitoring or measurement. And as I mentioned, these technologies exponentially enhance our ability to monitor and measure the natural world. So there are several initiatives around the world, one of them off the Pacific Northwest coast, to essentially digitally connect the oceans under the rubric smart oceans, right? So this entails a number of fixed and mobile sensors. Some of these are science-led, some of these are NGO-led. And so for those of you who are interested, this is one of the best examples, I think, globally of a multi-purpose digital network monitoring everything from fisheries to seismic. Another very interesting development in this field is the innovation of new types of monitoring devices. This is a slug bot. So it's a biohybrid robot. It was cultured from the muscle cell of a sea slug and affixed to a 3D printed biodegradable plastic device. I know it looks a bit like a retainer that went through the microwave, but it's very functional in a marine environment. And so this robot that was developed at Case Western University uses sea slug muscles and nerves to inch forward, and the actuators are actually the nerves. And so the result of this is that this is completely biodegradable after the end of its life, and is a new class, is an example of a new class of biohybrid robots that can monitor sensitive environments without generating e-waste. I devote a whole chapter in the book to biohybrid robots, including cockroach bots and a huge variety of bots you might not have known existed. So my point in showing you this is to signal that the sorts of innovation that are ongoing are as much to do with materials engineering, which raises some important ethical issues, as well as classic instrumentation. The second category of applications has to do with conservation. The most active area that we found was with robots, autonomous robots developed for conservation. This is a COTSbot. It's an underwater autonomous vehicle. It patrols the Great Barrier Reef, aided by computer vision. It injects crown of thorns starfish and invasive species by lethal injection. Now, there are many robots out there. One of the co-inventors of the Roomba, which I believe is the world's best-selling robot, it's that vacuum robot that moves around your home, also invented an underwater robot that used computer vision to suck up invasive species, kind of an underwater Avenger-style vacuum, I suppose. So there are many examples of these autonomous robots that are now being used for a variety of purposes. Some of them also are used to deter and protect endangered species. So pingers, for example, are widely attached to fishing nets. Acoustic alarms are embedded in the pingers. They emit frequencies audible to cetaceans, and this hopefully helps reduce entanglement and bycatch. And the next generation of these pingers actually have very small cameras installed in them. And the hope is that a better understanding of the behavior of cetaceans and turtles closer to nets will improve the conservation and IUU. A third category of applications is hazard prevention. So here again, 2 illustrative examples, river track. This particular application installs sensors on a bridge or some structure just above the water. So in the context of climate change and challenging flood control in lowland areas of England and Wales, this now constitutes a real-time alert system with a high degree of spatial resolution and very, very real-time, immediate response to signal flood warnings. Scaling up, this is a very typical example of the large-scale data sets we're seeing. We have about 650 data sets that we're tracking that aggregate some kind of environmental data for the purposes of conservation. This one happens to be hosted by the WWF, and I picked mostly water examples because my research specialty is on water. So this is a portal for current data on freshwater ecosystems and species. The other interesting point to note about these data sets is despite the challenges of data integration, there's an increasing move to aggregate multiple types of variables that were previously largely sequestered within specific disciplines, raising very serious issues of metadata and standardization that I'll return to later in the presentation. The fourth category that I explore in the book is citizen science. There are literally thousands of applications out there. I've just put in a fun one. Smart surfboards with sensors that measure ocean parameters and shared in real time with the scientific community. This one measures temperature variation and ocean acidification. Here's another one I really love. I think you'll know this one well, so I won't say much about it, but none of these applications would have been available, of course, without the ubiquity of smartphones. And we live in a world where more people have smartphones than have access to electricity. So this is a profound transformation in our ability to source and harvest data, but also incite environmental action at a local scale. The final set of technologies, immersive technologies. This is a graphic I came up with to try to parse the quite complicated landscape of immersive technologies. On the one hand, you have augmented reality, on the other, virtual reality. That is the vertical axis. On the horizontal axis, awareness and activism. And so if we look at the four quadrants, there's one set of these technologies that simply seek to raise awareness through using augmented reality. I've given the example of the After Ice app. If you download it and you're in a city like New York, all of a sudden, as you point your phone around you, you realize that most of where you're standing will be underwater. In the upper right-hand quadrant, augmented reality and activism. So there are a large set of apps that seek to incite environmentally friendly behaviors, again, using simple, usually smartphone apps. This one uses digital experience to tell people what can and can't be recycled. In the bottom left-hand quadrant, virtual reality and raising awareness. A huge number of environmental NGOs and even major corporations have created VR experiences. Climate change is the most popular category. And finally, virtual reality and activism in the bottom right-hand quadrant. There is some very interesting research on this showing that virtual reality has demonstrable and long-lasting effect on research subjects exposed to VR rather than conventional video. And I'll return to some of that evidence later in the presentation. But just let me give you some examples of what this actually looks like. Here's one example I love. It's from the Jeremy Bailenson lab at Stanford. These are fish avatars. So real fish are tagged with electronic sensors in Monterey Bay, just off the California coast. The sensors transfer that movement data into a virtual reality of fish where humans are observing the virtual versions of the live fish. And that provides a real world basis for some of the VR experiments that Bailenson does in his lab. Here's one of those experiments. This is the Stanford Ocean Acidification Experience. Here you're seeing people in the Senate actually working their way through this experience. What Bailenson studies is the dynamics and implications of interactions among people in immersive VR. The particular VR experience here presents the viewer with a coral reef ecosystem scenario of rapid decline if emissions aren't curbed. And they're currently showing this to decision and policymakers and citizens around the world and are aiming to be one of the world's largest ongoing VR experiments. You yourself can actually participate if you go to the link here, and they'll help you set it up, run it locally, and add to their database. The final example I'll mention is of augmented reality, widely used for mostly gaming purposes, but there are a small and growing number of examples that I think have real environmental governance applications. This is an example of cameras installed along riverbanks, IoT, enabled with a dynamic GIS layer. And this is actually a hybrid between a monitoring network and an applied conservation network that can be used by land managers. So the reason that I gave you an overview of, I think I just gave you maybe 10 or 12 examples as a small subset of the over 4,000 that are in our database, is to give you a sense of the broad diversity of the applications that are now being invented. In many cases, they're reinventing the wheel technologically. And I think it's fair to say that some of the supports for this with respect to research data management, advanced research computing, research software are not yet fully developed. So I think we'll see some exciting innovations and perhaps consolidation of methods in the next 10 or 20 years across disciplines. Looking forward to that time, I'd like to offer the following analogy for this rapidly expanding ecosystem. And the analogy I offer in the book is that of a planetary macroscope. So to understand the significance of the macroscope, a little historical anecdote might be helpful. Many of you might know the story of the discovery of the microscope and associate it with van Leeuwenhoek. The actual inventors of the microscope were a father-son pair, the Jansons, who first superimposed two lenses 100 years before van Leeuwenhoek started using his microscopes. The Jansons were spectacle makers, which was a very lucrative, highly secretive industry at the time, based in the Netherlands. And at the time, they did not believe that their invention had any practical use because it didn't help their customers read any better. So they put it aside. And it was only about 100 years later that van Leeuwenhoek resuscitated the technology. And because he was, I guess, a very quirky individual, a draper's son who ran a fabric shop, was not a trained scientist, he began pointing his homemade microscopes at the world around him, at anything he could observe: well water, his wife's breast milk, his own blood, his own sperm. I mean, a very quirky individual. And the microbes he saw were so astonishing that he originally kept his discovery secret. He eventually shared his findings with the Royal Society in London that sent a delegation out, validated his findings, and the humble draper from Holland began publishing his research alongside notables like Newton, and the rest is history, as they say. But my point in sharing this anecdote is that I believe this planetary macroscope that I've laid out for you is as profound a discovery as van Leeuwenhoek's microscope. As I mentioned earlier in the presentation, it enables us to do things very, very differently. And I don't think we've even probed the full extent of what we will begin to discover. I think we can confidently say that at least two developments have already begun occurring. And the first, as I mentioned earlier, is enhanced cognition. That is the ability to make continuous observations temporally with comprehensive spatial coverage, generating a superabundance of data over an enhanced set of variables, leads to a phenomenon that social scientists call time-space compression. That essentially the amount of time and the amount of geographical scope it would have taken to derive research results a generation ago is vastly compressed. And as we do this, we enable ourselves to see patterns we didn't even know existed. And I think that we are just at the beginning of really important breakthroughs in understanding planetary systems. The second aspect of this revolution is enhanced sensing. And as I mentioned earlier, the ability to distribute observations between humans, computers, and autonomous instruments extends our sensing capacity, particularly visual, but also acoustic, infrasonic and ultrasonic. And this enables the instantaneous, as Tanya well knows, identification of species, but also individuals within species. This is a profound transformation in our relationship with the natural world. And I think the next frontier is at the integration of computer vision, bioacoustics, and ecoacoustics, which is only going to enhance that capacity. From a social science perspective, this is extremely promising, but also potentially worrying. Jeremy Bentham, an English philosopher centuries ago, coined the term panopticon, which was later taken up by Foucault as a metaphor not only for contemporary prisons, but contemporary life in a world where large bureaucracies, be they state or the private sector, have fairly complete surveillance power over populations. And there's been much debate in the social sciences about the negative and positive effects of the panopticon. In the book, I dive into this debate a bit further and ask what the implications might be of extending this panopticon to non-humans. So if we have a green panopticon or a planetary panopticon, what does that mean? In general, after many years of dialogue about this with natural and social scientists, I do see a pattern. When I was at Stanford, for example, on sabbatical, I spent half my time at the School of Earth, Energy, Environment, and the other half at the Center for the Advanced Study of the Behavioral Sciences. In the former case, natural scientists, in the latter case, social scientists. The natural scientists in general were intrigued, but thought there could be promise here in terms of addressing some of our most pressing environmental crises, and displayed the classic can-do mentality. I think that's characteristic of the natural sciences and engineering. On the other hand, my social science colleagues were much more cautious, worried about data sovereignty, privacy, human bycatch, and other important issues like indigenous data sovereignty, and queried whether it was even appropriate to be collecting this data at all. And so they displayed the classic, should we do this, rather than the can we do this, mentality of social scientists. And I, as someone trained in both the natural and social sciences, I occupy that a very uneasy, sometimes middle ground in my response to these debates. I think it's fair to say that with extensive caveats and appropriate safeguards, we can mobilize this green panopticon for useful purposes. And with that, I'm going to give you 3 examples of where I think innovation should occur to make real measurable positive outcomes for the environment in the next decade or 2. The first is mobile conservation. So some of you may be familiar with the very exciting work that's going on in this field. Marine environments have been more of a focus than terrestrial. So I'll mention a great example here, Sarah Maxwell's work with respect to marine protected areas. So the notion here is rather than a fixed park with static boundaries, the boundaries of your protected areas move. And they move in a fashion that is adaptive and dynamic and responsive to the needs of the protected species or the ecosystem. So a great example is the mobile protected area that is now used for bluefin tuna as they migrate between Indonesia and Australia. In the Great Australian Bight, the boundaries of the protected area might shift on a weekly or daily basis. And fishers would have to check in and ascertain which locations they're allowed to fish in every day and what behaviors are allowed in those locations. So that's a great example, and there are many around the world. And the recent work done at the Benioff Institute at UC Santa Barbara, identifying global biodiversity hotspots on the open oceans is a great starting point for where we should be applying these mobile marine protected areas systematically. The reason that this is relevant to a debate about the positive or negative aspects of digital Earth is because they are necessarily computationally intensive. We could not create or run these mobile conservation areas without a computationally intensive approach, because the spatial and temporal dynamism is so demanding in terms of real-time data and automated analyses. The other thing that excites me about this application is that new biophysical parameters can be incorporated into regulation. So typically maximum sustained yield models in fisheries would just focus on extracting maximum value from one species from an ecosystem. Innovative thinkers in fisheries science have proposed new methods like optimal renewable biomass, which is essentially a concept that would have us focus on optimizing the renewable biomass in an ecosystem rather than extracting from a single species. The real barrier to implementing ORB concepts versus MSY is that they are so data intensive. And I really, really believe that this approach will solve that. And in the future, we're going to be managing ecosystems, marine ecosystems, on this basis of renewable biomass and regeneration of that biomass rather than extraction of a single species. A second example I'm really excited about is third-party monitoring and enforcement. So one of my favorite examples is methane sat. To set the stage for why this is so exciting, let me just give a brief overview of third-party monitoring prior to this. So some of you may be familiar with the Forest Stewardship Council and the Marine Stewardship Council models. These were third parties, certification bodies that applied a chain of custody approach right from the extractive industry or the producer all the way through to the consumer. Very costly, time intensive, so small scale producers couldn't participate. They didn't deal with situations where there was a large degree of illegal resource extraction. And they were open to fraud because they conducted periodic audits rather than continuous. These new third-party models address those concerns. They're spatially ubiquitous, they're continuous, and because they're lower cost, they can include small-scale actors. So here's an example, methane sat. This is a joint initiative between the Environmental Defense Fund and researchers at Harvard. It's a satellite they have put up into space for the sole purpose of independently checking on methane emissions from oil and gas systems. And the goal is to lower methane emissions by 45% by 2025. And so what they've done is targeted 200 priority targets, be they single polluters or regions where there might be intense, for example, hydraulic fracking. And by revealing the data about fugitive emissions, for example, in real time, they are seeking to drive enforcement, under enforcement and lax regulations being a big issue in this sector, particularly in the fracking industry. So this sort of enforcement, I think, will proliferate, and it presents a ton of interesting scientific questions as well as environmental conservation questions. The third and final example I'll talk about is just-in-time conservation. There are many instances where we have immediate crises, particularly with respect to endangered species, and we don't have long-term solutions, but we now have the ability to use digital Earth tech to provide at least temporary environmental fixes. A great example is bird returns. So this is a collaboration between the Cornell Ornithology Lab, their eBirds Citizen Science Birding Network, and the Nature Conservancy. And the problem they were seeking to address arose in the Central Valley in California, where a large proportion of North America's migrating birds had previously sheltered, stopped over in wetlands that have now largely disappeared due to intensive industrial agriculture, but climate change has further exacerbated this issue with a number of wetlands reducing in size or disappearing altogether with recent droughts. So what Bird Returns does is it pairs birders and farmers. And the way it works is the location of the birds in real time is determined through a combination of sensor satellites and citizen science observations through eBird. Likely locations for the desirable wetlands are established. These are somewhat systematic from year to year. And then an Airbnb style rental model for pop-up wetlands is applied. Essentially, the Nature Conservancy is renting the wetlands from farmers, and the price is determined through a reverse auction. What this leads to in practice is farmers flooding their fields in critical periods, for example, February, before a lot of rain has fallen, but when birds are arriving. And this creates pop-up wetlands that are temporarily available to the birds where and when they need them. So the initial findings on the results are quite promising, with an increased abundance of waterfowl and shorebirds, and also an increased diversity of species. And I've just put up one of the references here in case you want to follow up. It's a great example. Now, there are significant challenges, and I know I'm nearly out of time, so I'm going to run through these pretty quickly, and maybe we can talk about them in the discussion period. I am very well prepared when I published this book for a barrage of criticism, particularly from my social science colleagues. Let me outline some of the challenges as I see them. The first is that there are enormous data challenges. And in fact, I'm painting a picture of sort of simplistic, happy solutions, when in fact behind that, we haven't solved a lot of the underlying data challenges from a technical perspective. Here are some of those challenges. Local data processing is still a huge challenge. In many cases, we simply haven't developed the communication and coordination protocols necessary. And it is a non-trivial task to integrate data across different sensor networks, in part because there are very distinct observational needs arising from different fields. The example I've given here is that meteorology and oceanography take a web of flows approach to their science, versus wildlife biology and ecology take a web of life approach. And it's the actual distribution of sensors, for example, is very, very different in these different fields. And so trying to overlay the data is very complicated. I think this can be solved through better metadata generation and management. It's not a trivial task, but it's not an insoluble one. Similarly, I think the whole quality control of sensors argument is something we can address. There is a trade-off in terms of security and reliability versus cost. And I don't think we're yet at the point where we have a sufficiently high threshold for reliability that we can always use these sensors for real-time decision-making. And so we'll need to build in a higher degree of redundancy into our monitoring and automated regulatory frameworks now than we might, decades from now. I think all of these are actually solvable, at least in some use cases, but there is a bigger caveat. Even though high quality, low cost, robust GeoWeb data will be widely available at some point, this doesn't necessarily enhance environmental governance. We all know that better data and better science doesn't lead to better decision-making on the political side of the house. And so there are many regulatory and legal challenges that will have to be addressed. So one of the tasks I'm working on with UNEP is the start of an ambitious agenda to create some guidelines for overhauling legislative and regulatory frameworks. Much of our environmental legislation arose from a pre-digital era. So, if you cast your mind back to the 1970s and 1980s acid rain debates, it was a huge innovation at the time to regulate sulfur dioxide through faxing data back and forth on a weekly, monthly, I don't think they did it on a daily basis, in order to apply a kind of rudimentary fine system to polluters across the US-Canada border. So if we think that legislation was essentially evolved in an era when fax machines were highly innovative, you see the need for overhauling our legislative and regulatory frameworks. I actually think that some of the leaders in this will be that small group of nations that have done a relatively good job at overhauling their own digital infrastructure. That's the Digital Nations Collective. So there's some Baltic states, there's Canada, aided by some innovative international organizations like UNEP, but I do think this will take decades. It won't be fast. Another key challenge is global transparency of data. So as I mentioned, much of the environmental data being collected right now is sequestered in separate silos, and an increasing proportion of this is being controlled by private actors. Let me give you an example. There's a very innovative startup founded by some ex-NASA engineers in San Francisco called Planet. They run a network of nanosatellites around the Earth. And they're an interesting configuration of satellites. They run them in small groups they call flocks. The nanosatellites are nicknamed doves. And they essentially operate like a line scanner moving over the planet very, very quickly. So they were the first to achieve the daily scanning of the entire Earth's surface a few years ago. You may have seen the TED Talks. And their next goal is to render the entire surface of the Earth searchable in real time. So much like we can use Google right now to search data repositories or repositories of videos or images, we will be able to use a search engine powered by Planet to Google the surface of the Earth in real time. So I'll be able to say, query how many cargo ships are there in the port of Vancouver at this moment? How many are entering and exiting per unit of time? How many refugees are walking in that column trying to escape Syria? I mean, the applications for humanitarian and environmental purposes are enormous, but there are lots of potentially negative applications. And of course, whether or not this should be controlled by a private company is a matter, I think, of real debate. That leads to the third point here, which is the growing involvement of non-state actors. I highlighted the emergence of a rapid proliferation of citizen science in terms of gathering data, but there is a lot of debate about using citizens to not only monitor, but enforce. The last point I'll mention here, which is actually very significant, is that this debate has, for a large part, left out issues of Indigenous data sovereignty. So there's a large proportion of the surface of the terrestrial surface of the Earth, which is under Indigenous stewardship. It's very relevant to the environmental management debates here in Canada. And research shows that biodiversity is higher on lands managed by Indigenous peoples, and they have robust and, I would say, expanding claims to environmental stewardship, for example, through the UN Declaration on the Rights of Indigenous Peoples. The current assumption in computational sustainability or conservation tech is that the data that is collected with our devices is not owned by anyone, but Indigenous scholars and communities would argue that they actually own that data, or perhaps the non-humans that we are studying themselves own that data. That is, in our rush to gather data about the environment, for a good cause, environmental conservation, we are actually inadvertently embarking on a new wave of colonialism. And it's an insidious kind of eco-colonialism cloaked in rhetoric about climate change or biodiversity protection. And so there's some very interesting arguments here offered by Maori scholar Tahu Kukutai or Jason Lewis at Concordia, who are making very, very significant arguments, I think, about the need to acknowledge Indigenous data sovereignty and work out better data sharing frameworks, which may lead to some data not being published at all. A final set of challenges, ethical challenges. You're very well aware, I'm sure, of debates about ethical issues with respect to digital tech and human society. Similar arguments apply in the case of Digital Earth, with respect to exploitative modes of recruitment, algorithmic bias. And thirdly, I'd mention environmental impacts. The energy demands from instrumentation and the data processing we're talking about doing are significant. You probably are familiar with this statistic that if the global internet were a country, it'd be the third largest emitter worldwide. These are very significant emissions that are only exponentially increasing. We haven't really got a handle on. And finally, e-waste. The majority of sensors and instrumentation devices are not yet biodegradable, notwithstanding my example of SlugBot. And so we do face the issue of an e-waste problem unless we accelerate innovation in biodegradable sensing devices in particular. So I'll conclude by scaling back out. This is my last thought I'll leave you with. And the thought is this. One of the most profound things that the Digital Earth agenda does is change the narrative. There were three dominant narratives of environmental governance in the 20th century, and I've listed them here and I've illustrated them with covers from Wired magazine. One dominant narrative was dominion, the notion that we rightfully exploit and manipulate the Earth. And the Earth is a sort of machine that we can tinker with and we should tinker with. A second narrative is that of communion, very often expressed by environmentalists who would articulate a view of the earth as inherently fragile, the earth as having certain limits, and would have pointed to a need to reconnect personally and physically with the environment in order to scale back, let's say, on the misguided path of industrial capitalism that proponents of dominion promote. A third narrative that's less frequently mentioned, but I think is equally important, is of course the narrative of escapism, with some of our wealthiest tech CEOs investing in off-planet space exploration. This is very timely. This particular cover of Wired is from this year, right after their Earth Day cover. And that issue of the magazine is full of articles on topics like, what kind of food will humans eat in space and how can we make it more tasty? So this narrative about Earth is very much about the Earth as a disposable cradle, which we can essentially use up and pollute without a lot of worry or even guilt, because there are lots of other planets out there. So I think the image of the melting scoop of delectable ice cream to symbolize the Earth is a very apt summary of that narrative. So one of the issues I think that blocked progress on environmental governance in the 20th century, in addition to sparse data, in addition to the technical issues I've mentioned, is that we were stuck in these narratives. They were not productive narratives. We couldn't move forward. And I do believe that Digital Earth offers us new narratives. And these are narratives I explore in the book. In fact, these are the basis for the book's structure. The first part of the book deals with regeneration, the second with communication, and the third with sympoiesis. And I'll briefly talk about some of my thinking around these narratives, and then we'll open it up for discussion. So in contrast to the Dominion narrative, I think we're entering a new phase where regeneration and regenerative sustainability will become the new normal. What do I mean by that? Whereas in contrast to sustainable development, which sought to reconcile perhaps the irreconcilable notion of economic growth and environmental preservation, while not attending to essentially a degrading baseline globally, I think regenerative thinking is not only more widespread in the scientific community and the conservation community, but now going to be enabled by Digital Earth technologies. So Rob Jackson's work at Stanford on regenerating the atmosphere is a good example, and there are many others. And I think the move away from thinking about single species extraction or oil and gas or fossil fuel extraction to ecosystem-based management models, the dynamic and adaptive management of which was pretty much technically impossible 20 years ago, will shift a lot of thinking. I'm under no illusion that we're there yet, but I do believe this is a very interesting interdisciplinary opportunity for scientists interested in new narratives for environmental conservation. The second narrative that I'm exploring has to do with communication, and I didn't have the chance to even tell you about that in this presentation, but very briefly, bioacoustics and to a lesser extent ecoacoustics research is revealing very surprising and in some cases inspiring things about non-human communication, not only amongst the usual suspects like birds, but also a broad range of species, including fish, crustaceans, and even plants. That is the ability of non-humans, and I know this sounds a little science fiction, but this is all robust research. The ability of non-humans to both hear and make sound is much more widespread than we previously thought. This has been taken up by a number of scientists and tech innovators. So for example, Microsoft has invented a prototype app that lets you speak to your plants. I'm not joking, you can look it up and I'd be happy to send you the reference. So we're in the infancy of developing these technologies, but the second part of the book devotes 4 chapters to explaining how they might unfold and the possibilities that this might raise with respect to two-way communication between humans and non-humans. The third and final narrative is that of sympoiesis. So sympoiesis is a term that was coined in contrast to the concept of autopoiesis. Autopoiesis referring to a boundary-defined self-assembly process, and sympoiesis referring to a porous or non-existent boundary of mutual collaborative assembly. So much thinking has been devoted to this across many disciplines. A concrete example is the work of some computer scientists in thinking through what an artificial intelligence infused future looks like. So Manuela Veloso, head of machine learning at Carnegie Mellon, refers to this as symbiotic autonomy. The notion that you are still autonomous agents, but existing in a much more symbiotic relationship. Sympoiesis is the term used by social scientists to express much the same notion. Now, in a very short space of time, I can't expand on this concept, but I'd love questions about it. But very briefly, what sympoiesis addresses is the following transformation. The tools humans used in the past to manipulate the environment were separate from humans. We could put our tools down at the end of the day, we could step away from our computers. But the tools that we're now talking about using to manipulate the environment may be increasingly infused in our own bodies. And technologies like biohybrid robots, CRISPR, machine learning, and especially the new emergent range of haptic technologies are all examples of this, where increasingly the divide between humans, non-humans, and machines is increasingly blurred, and we proliferate cyborgs, chimeras of various kinds, not without significant ethical issues. In the book, I explore the very emergent, nascent attempts to create practical applications in this area. And I think there's some very promising ones, particularly in the field of infrastructure, where some computationally intensive co-design methods between engineers and living species, like silkworms or honeybees, are being used to create really imaginative structures that are truly co-designs between humans and non-human species. So this is, of course, the most speculative part of the book, and I don't want to leave you with the impression that I believe this will come to pass, but I do feel that what's most enticing about this digital Earth ecosystem is its ability to generate new narratives. I'm not sure whether these narratives will come to be the ones that will dominate in the 21st century, but I do think we're at a very interesting period where we are evolving new narratives and hopefully breaking us out of the very stale, polarized debates about environmental action in the 20th century. With that, I'll conclude, and I'll look forward to your questions.
Thank you, Karen. And this is for a wonderful talk. And we have already a question, and I have many, many more. We have a few minutes. So a question from Harvey Miller, a fellow faculty in geography. A danger in data-enabled urban science and governance is focusing on things that are easily measured and neglecting things that are difficult to measure. So we can measure, for example, in cities to count cars or count pedestrians, but it's hard to plan for the, so we plan for the former rather than the latter, right? And so it is easy to measure economic efficiency, but difficult to measure social equity. What do you think are the dangers in environmental governance, and what are you afraid of missing?
Yes, excellent question. So, I mean, there's an obvious sort of parallel at a quite simplistic level to your point that as we expand our environmental governance applications, we will be only imperfectly measuring attributes of any one ecosystem. And in so doing, because ecosystems are interlinked and complex, we may do more harm than good, which we may only realize in retrospect. So I think there's a very practical aspect to this, which has to do with overhauling our understanding of the precautionary principle, whereby the precautionary principle is not only about not acting when you're unsure of the harm you would cause, right? But also acting in such a way that doesn't negatively affect the organisms or attributes that you cannot measure. So I think an overhaul of the precautionary principle here, and I've not phrased it wonderfully, but you can see where I'm heading, is desired. I think there's a more fundamental question here also about the anthropocentrism that we apply when looking at non-human ecosystems, and the choice of where we look and the choice of what we measure. So for example, in the work we did looking at bioacoustics, I was just curious, which species are we listening to with these digital devices? It turns out there were well over 1,000, and there was definitely a bias. We were listening to certain kinds of, I would say, charismatic megafauna, charismatic minifauna also, and neglecting lots of other species, so that there's a kind of anthropocentric bias to our digital earth gaze, if that makes sense, that I think will likely persist for some time. I think another interesting issue arises in the distant future. Let's say in some science fiction future, we did arrive at a point where we, panopticon style, were able to monitor all organisms in an ecosystem. Maybe unlikely, maybe impossible, but let's follow me in the thought experiment for a minute. In this fictitious future speculative scenario where we're able to monitor all species and we're then able to start intervening in ecosystems, there will be instances not only of neglecting things we can't easily measure, but having to arbitrate or adjudicate between sometimes competing demands in those ecosystems where we favor one species over another. And I actually think that's an equal or greater danger. That is the ability to monitor ubiquitously does not remove the issue of bias. It just shifts the bias from the choice of what to monitor versus not monitor, conscious or not, to adjudicating in favor of certain ecosystems that favor certain species. And so I think this is a kind of inescapable tension. That is, I don't pretend that what we are now doing is going to solve the tension you outlined. It's as fundamental a problem as the conundrum of human tools. I mean, humans innovate tools, and then we can use those tools to repair or regenerate or do harm. Do we harm or heal? This is a perennial issue that won't go away. I think the only thing we can do as social scientists is to evolve better frameworks to be more thoughtful about how we do this. And I think that's, unsatisfactory at one level, but realistic at another. I hope that was helpful.
Thank you. Do you have time for more questions?
I do. I shifted my meetings around and I can go till 10:30. So I don't know when you finish, but.
So we do have time for questions then. And so that was a question from Harvey Miller before. And this is a question from Bhavik Bakshi. A fundamental flaw in the modern engineering paradigm is that it takes nature for granted, as you pointed out. We ignore what nature does for us and its limits. If we don't address this problem, digital Earth may just lead to more of the same, more e-waste, more ecological degradation, etc. What are your thoughts on avoiding this situation with these new technological abilities? So following up on your list of challenges.
Yes. Yeah, of course, all of the technologies I mentioned could simply be used to accelerate exploitation. We could, we have precision agriculture. We could also have precision fishing and precision hunting. There is nothing innate in the technologies that would steer them towards regeneration and environmental conservation rather than environmental exploitation. And I think you're right in arguing that some disciplines have more strongly dissociated themselves from this issue than others. So I think there's a few different types of solutions. One is technologies can have inbuilt safeguards. The second is that the transparency of environmental data can enable effective oversight. And the third is an interdisciplinary transformation where digital earth engineering, for lack of a better word, attracts a very different type of mindset and worldview. And I would hope that emergent and now establishing disciplines like computational sustainability and ecological informatics would be in consultation with engineering departments for precisely that reason. I know that for the moment, that's not really happening. So one of the interesting things as I was researching the book is the lack of dialogue between, for example, people doing ecological informatics and people in engineering departments creating biohybrid robots. There's not a lot of dialogue yet, but I think there could and should be. And I think we are capable of creating the scientific norms and the technological norms that could govern these systems. Now, whether or not we'll apply them is a question I can't answer. I take heart from some of the conservation tech innovation ecosystem. I didn't have time to talk about it, but there's thousands of companies springing up, run by mostly young people under the age of 35 who identify simultaneously as engineers. They build cool tech. In environmental scientists, they want to understand why and how the natural world works. And environmentalists, they want to intervene to protect the environment. So I take that as a very positive sign. I'm on one Slack group focused on AI and conservation with over 1,000 members. So I'm not saying that will solve the problem, but I'm saying that I'm seeing promising developments even within engineering that make me a little hopeful.
Thank you. So I have a question. And you touched at the very beginning upon it, that this confluence of our ability to get information, to get more data, that then feeds into policy decisions and actions, and quite often our understanding, all of which may be biased. How do we engender trust in the solutions that come out based on this technology, based on those data, particularly when the policy decisions and, such as conservation policy, is quite often enacted in places which did not create the technology, where the technology is imported for those locations. So how do we engender trust all the way from and across the globe in these decisions?
Mm-hmm. And I think that speaks to some of your own work, as I understand it, in East Africa, where engendering trust was one of the necessary steps for uptake and positive outcomes. So I appreciate that you yourself have an example of having done that in your own work. At a general level, how we engender trust is, I personally believe, through establishing an environmental data commons and having a kind of environmental information democracy. That is, the data must be accessible. Transparency in algorithms is the next key step. And then I think, thirdly, using where appropriate and possible, a combination of citizen science and a multi-layered tech that includes what in the development world used to be called lowest appropriate technologies, or this is going to be required. That is, the deployment of any particular technology will be layered with sets of additional and perhaps slightly generic, essentially consumer-facing technologies. So I'll give you an example of the work I do myself. For the past 6 years, I've worked with Indigenous communities in Northern Canada. They are often living in fairly remote areas, which may be fly-in only or boat-in only areas, where they are still somewhat dependent on subsistence hunting and fishing for food security, and yet where an increasing amount of mining and hydraulic fracking, unconventional oil and gas development, is occurring. And there's a lot of concern about water quality. In a context where there's very little water monitoring done by the government, So what we've been doing as a team is working with Indigenous community organizations to create multi-layered water monitoring networks, some of which really are just run by the scientists, but one layer of which is actually created and run by the community. And we've devised low-cost water monitoring device that can be built. It's a DIY model. You can build it with mail order parts, very inexpensive sensors you can just order. And Amazon delivers everywhere, including the Canadian North. And so we've developed and tested with youth in these communities, building their own water sensing devices that can be towed behind a boat or fixed to a tree or a bush. The devices measure easily understandable variables like electrical conductivity and location, GPS, so that these communities, the way we frame it with them is this is like a burglar alarm. So if there's a rapid change in electrical conductivity or someone moves your device, then you would want to alert the team you work with, and grab samples, and other work can be done to ascertain whether there is a pollution incident. And the buy-in from the communities has been tremendous, because all of a sudden they are actively leading one of the key aspects of a multi-layered monitoring system that is both top-down and bottom-up at the same time. So that illustrates a few more general points, that the technologies that we're building will combine, I think, aggregates of very simple and very complex technologies, some of which will involve citizen contributions, where citizens feel they are a vital part of monitoring and to some extent in charge of monitoring. And that leads to greater buy-in for the eventual results. And actually, in an interesting way in this context, brings more people out onto the land than otherwise might have been there. I don't think that's sufficient. Returning to my earlier points, I think you also need the algorithmic transparency, the environmental data commons, and these overarching frameworks that I think are best set at an international level. And that's why I'm really keen on the work that UNEP is now leading. They brought some of these issues to the UN high-level forum, which is the world's leading forum for discussing new policy innovations. This is also very much a focus of the current German presidency of the European Union. They published a really interesting report on sustainability in a digital age a year or two ago, and they view the confluence of digital innovation and sustainability as a hallmark of innovation in Europe in the 21st century. So that's a likely place where some of these norms, which are in some ways an environmental analog to GDPR, are likely to emerge. So I'll stop there.
Thank you. Yeah, those great examples and great thoughts. And we still have questions. So this is a question from Matthew Walker, who actually has several questions. So we'll start with one. With regard to intertwining of humans with technology and environment, are you familiar with Timothy Morton's hyperobjects, philosophy and ecology after the end of the world? And if so, what would you say? Sorry. And if so, would you say this is an accurate theoretical model for the way our agency and subjectivity has been obscured throughout the course of the Anthropocene?
Yeah, I mean, so the book, I think, will disappoint those who want a deeper discussion of some of the social theory debates around this. And so I'm familiar with Timothy Morton's work on hyperobjects. I don't actually go into it in the book. There's, there's a longstanding, very rich debate about whether it's Haraway, Simian, Cyborg and Women, or Latour, We Have Never Been Modern, or more recent work, which I really enjoy, by Timothy Morton or Jason Moore, right? A kind of a ecological critique of capitalism, not to mention all the greening of Marxism debates with O'Connor, Enrique Leff, and others, that all speak to, let's say, a social theory infused perspective on the evolving relationship between humans, non-humans, and machines, and our conceptual framings of that relationship. So within that broader debate and within that lineage, I think hyperobjects is one useful lens. I feel like, and don't take this as a critique, I love his work, but the book I'm writing for Princeton University Press is a trade book. It's meant to be accessible to a general audience. And one of my goals was just to lay out all the technologies that exist. And in spite of the caveats, and I know this will be probably controversial, inspire a bit of hope, whereas a lot of social theory discussions are remarkably insightful and precise. My goal was not, let's say, that level of nuance, but rather I sometimes frame it as a kind of Gramscian style. You know, we rightfully have pessimism of the intellect, but it's a time for optimism of the will. That was his saying back in the prison notebooks, I believe. And I would add a third thing that he didn't add, which is playfulness of the imagination. That is, one of the problems I see in the current debate is a divide between the social scientists whose wonderfully nuanced and elaborate critiques don't speak to or provide a handle that natural scientists can grab onto to guide their development of these technologies and their collaborations and move the debate forward in a structured and principled way. And so my book is trying to occupy that. It's an uneasy middle ground where I think the social theory focused scholars will find the book light on social theory. But my goal is elsewhere, to stimulate action in spite of the barriers or the challenges.
Thank you. And I think with that, we will wrap up the recorded portion of the talk and the Q&A. And I want to thank you, Karen, again. We can stay on for a little longer and just talk and switch to a more informal format. But I really enjoyed the talk, and I have thousands of questions that we will continue this conversation. So thank you very much. And you would hear now an audience applause. And I hope that we will be able to host you in person and have continue all these conversations in not too distant future, hopefully, way before we get to the to your sci-fi view of digital.
Yes, yeah. Thank you.